Welcome back to the series of video lecture on thermodynamics. In this video, we will talk about isochoric process and isobaric process. We already mentioned we talked about isothermal process. In an isothermal process, the temperature is constant. Therefore, the change in internal energy is zero. In an isochoric process, constant volumetric, constant volume process. So if the volume is constant, which means a change in volume is zero. So if we consider the work done from going from a state A to B in a pressure volume diagram, dV equals zero. So 0 multiplied by anything is 0. From the first law of thermodynamics, delta U is Q plus W. And since our W is 0, it means that delta U is equal to Q. It's customary to write delta U, change in internal energy, to be equal to QV, where V indicates that it is a constant volume process. A constant volume process is often carried out in what is called a bomb calorimeter. A calorimeter is any device that is used to study the heat of chemical reactions. In a bomb calorimeter, the device is enclosed in a strong metal casing, and then we have a valve where gas is allowed to go in. Remember that gas fill up the volume in which they occupy. So the gas that's allowed in can also be sparked, and whatever process is allowed to carry on. This bomb calorimeter, for those in engineering, it's similar to what is in the hood, under the hood of the engine of the car. So the heat supplied to the system is often given as the IVT, where I is a current from a source of known potential difference. So the small letter V is a voltage, and transferred for a known amount of time. Then we will talk about the concept of heat capacity soon. The heat supplied is also equal to the heat capacity, or specific heat capacity multiplied by the change in temperature that's observed during the combustion of the gas. So we also have a constant pressure process. So we talk about, now we've talked about the constant temperature process, constant volume process. Now we look at constant pressure process, and we talk about another state function, the enthalpy. The constant pressure process is a process that's being carried out at constant pressure. For a constant pressure process, the change in pressure is equal to 0 because P1 is equal to P2. Since W is minus P delta V, W is not equal to 0. Recall, we say it's a constant pressure, not a zero pressure. So work done is not 0. Therefore, our delta U from the first law for a closed system is equal to Q minus P delta V, because it's Q plus PV. If we rearrange this equation, we arrive at QP equals delta U plus P delta V. In the chemical processes, QP, because most chemical reactions are taking place at constant pressure, QP is called the change in enthalpy of the system. And the enthalpy, the new thermodynamic quantity that we're talking about, enthalpy is U plus PV. That's in its mathematical definition. It's the sum of the internal energy, which is the energy as a result of spatial arrangement and internal motion, plus an associated pressure volume work. So if we consider change in internal pressure, that would be change in internal energy plus change in the pressure volume work. So from mathematics, we know that delta, the change in a product of two functions means that you keep one of them constant, so keeping P constant and varying V, plus keep V constant and varying P. So change in H is change in U plus P delta V plus V delta P. If we consider what happens at constant pressure, delta P equals 0, so this term goes off, so we have delta H equals delta U plus P delta V. If it's a small change, we can easily write dH is du plus P dV, and at constant pressure, dH is delta U plus P delta V. Okay, so back to this equation. This equation at constant pressure, delta H, which equals delta U, change in internal energy, plus pressure multiplied by changing the volume, is identical to this equation for QP for an isobaric constant process. So the heat content is the change in enthalpy at constant pressure. Note that Q is not equal to H. QP at constant pressure is equal to change in internal change in enthalpy. Okay, like the internal energy, the enthalpy is a thermodynamic measure. So enthalpy is a thermodynamic measure of the thermal energy in a reaction. So it is a state function, meaning that it depends on the state of the system, unlike Q. But this is under a certain condition. And it is an extensive quantity, which means it depends on the amount of substance present in the system. The enthalpy changes of constant pressure processes are also referred to as heat of the processes. For example, if there's an enthalpy change in a neutralization reaction, we call it the heat of neutralization. So in the next videos, or a couple of videos, we will work sample questions on the different processes that can occur. There's one last process that we'll talk about, the adiabatic. We'll come to that in another video. See you in the next video.